Welcome to Finite Math, Chapter 3, Section 3, Day 2, Sum and Difference Formulas with Solving Cosine and Sine. So these sum and difference formulas we oftentimes end up using not to make things bigger and find precise values, but in order to make things smaller so that we can solve more efficiently. So we're looking again at the idea that if y equals the cosine of theta, then we can take the cosine inverse. And again, theta, generally, your primary value is going to exist between 0 and 180. Cosine inverse equals the principal value, or your calculator answer, plus or minus 360 degrees any number of times, or plus or minus 2 pi any number of times. Second answer is the opposite of your principal value, or whatever the calculator says, plus or minus 360 or 2 pi any number of times you might need. When y equals the sine of theta, then you get, again, principal value plus or minus 360 any number of times. Your principal value could be negative or positive, between negative 90 and positive 90, or between negative 2 pi and positive 2 pi. Your second answer is either 180 or pi minus your principal value plus or minus 360 or 2 pi any number of times. Just a little review about solving. And the tangent inverse equals the principal value plus or minus 180 any number of times, or plus or minus pi any number of times. So we need to solve each of these trig equations. We want to write the general solution for that particular angle equation, and then find the particular solutions that only exist between 0 and 360. So if we have cosine minus sine, that sounds like a cosine of a plus b situation. So it looks like a is theta and b is 36. So we're actually looking at the cosine of theta plus 36 degrees. And that is going to equal root 3 over 2. Looks like with some of these values, these show up on the unit circle. The cosine of root 3 over 2 is just 30 degrees. We could also check that with the calculator if we're in degree mode. I'm in radian mode, so let's get in degree mode. So the cosine inverse of the square root of 3 divided by 2 is, again, 30 degrees. That's our principal value. Cosine inverse of the cosine of theta plus 36 degrees equals the cosine inverse of root 3 over 2. But remember, when you take a cosine inverse or a sine inverse to get rid of a sine or a cosine, then we're going to end up with two different answers. So theta plus 36 degrees is either going to equal what the calculator said, 30 degrees plus or minus 360 degrees any number of times, since we're in degree mode, or the opposite of what it said, negative 30 degrees plus or minus 360 degrees any number of times. Now, I could have said plus or minus 30 there and kind of saved myself a little bit of space, but I didn't, because I actually have two equations now where I need to subtract 36. So one of these equations is from the top, where theta plus 36 could equal positive 30 degrees plus or minus 360 degrees n any number of times. Part of what that n does for us, again, is it makes it so that the 36 is not like terms with it, so we can really only subtract the 36 from the 30. So we get theta equals negative 6 degrees plus or minus 360 n. That is one of our general solutions. The other general solution comes from theta plus 36 equaling negative 30 degrees plus or minus 360 degrees any number of times. And now when we subtract 36 degrees from both sides, we get a different number. We get theta equals negative 66 degrees plus or minus 360 n. And that is our second general solution. The particular solutions are the ones they asked for, between 0 and 360. Both of those numbers are negative, so we can't use either of those. Those are smaller than 0. But if you take negative 6 plus 360, you get a positive number, 354 degrees, which is between 0 and 360. And if we take our negative 66 and add 360, the other particular solution is 294 degrees. And those are the only two that work. If I keep adding 360, I get more than 360 afterwards. Example 2 is quite similar. The sine of 2 theta times the cosine of theta minus the cosine of 2 theta times the sine of theta. That sounds like a sine of a minus b, since that's a minus sign. So we're looking at the sine of 2 theta minus theta equals root 2 over 2. I can do this one without the unit circle because the sine that is root 2 over 2 would be the sine of 45, but that's only one possible answer. But I'm getting ahead of myself. 2 theta minus 1 theta is only 1 theta. So the sine of 1 theta equals root 2 over 2. Now we can get rid of the sine by taking the sine inverse of both sides. Inverse of a sine will cancel those out. And then we'll take the sine inverse of root 2 over 2. Time to switch pens. There we go. Let's pull ourselves up here a little bit. So that means theta, our angle, we don't have to add or subtract anything. The calculator says 45 degrees, or the unit circle says 45 degrees. Generally plus or minus 360 degrees any number of times. The other answer is 180 minus our principal value, plus or minus 360 degrees any number of times. Remember, you do actually need to simplify like terms whenever you can. So theta could equal 45 plus or minus 360. We don't need to change that, but 180 minus 45 is 135 degrees plus or minus 360 n. And those are our general solutions. Theta could equal the 45 variation, or the 135 degree variation. And then the particular solutions between 0 and 360 that they asked for, 45 and 135, are already those numbers. They fit the parameters. If we add 360 to either of them, we're going to get a number that's bigger than 360, so those are out. If we subtract 360 from either of them, we're going to get negative numbers, so anything subtracted is out. That's all we've got for this particular example, or this particular set of solutions. Let's also look at a tangent example. So tangent example, we have the tangent of 2 theta minus the tangent of theta over 1 plus the tangent of 2 theta times the tangent of theta. That looks like a tangent of a minus b. So this is really the tangent of, again, 2 theta minus theta equals root 3. Again, 2 theta minus 1 theta is just theta. And we can take the tangent inverse of both sides of this equation. To get the theta by itself. And again, tangent inverse of root 3. We could use the calculator. If you have a unit circle chart, you could also do that. Tangent inverse of the square root of 3 is 60 degrees. That's our principal value. Plus or minus 180 degrees any number of times. Remember, tangent special, it only goes plus or minus 180. That actually takes care of it having 2 different answers and rolls them into one so that we can write less. So the particular solutions between 0 and 360, well, 60 is definitely a number between 0 and 360. And let's see what happens, how many times we can add 180. If we add once, we get 240. That's another number that works. It's between 0 and 360. But after that, too big, so we can't keep that one. And that's example 1.